All right, so I just made this video, but I have to make it again because I didn't press record, so sorry. I had a request for homework number 6, rotation 2, which is basically what's the magnitude and direction of the angular acceleration of the cylinder. So first of all, I'm going to look at this picture and realize that the first part is a torque problem. Remember, torque is defined as R perpendicular to F, and so what I'm going to do is look at each of these values of R, and I draw from the point of rotation out to where the force is applied. What's nice about this problem is 3 of the forces are perpendicular to R, and this one's parallel, so this one has no torque. So that turns out somewhat simple. Then I go through and I kind of pretend like I'm pulling on each of these forces as if it was a string wrapped around this disc, and I think about which way this would spin. So I have a positive torque 1, remember counterclockwise is positive, clocks are negative, minus torque 2, minus torque 3. Then it's really a matter of just going through the problem and taking the radius that they give you times the force of pull. All right, so then the next piece of this problem is that I need to look at Newton's second law of rotation, which looks something like the sum of the torques equals I alpha. Well, what I think I'm going to do here is take my answer from up above, I haven't calculated it, but it's just some number, equals I times alpha. Now, this is a disk. Now, since we apparently are having an open note test, it wouldn't hurt you to know and actually write on a card somewhere as we get organized that a disk has a rotational inertia of 1/2 mr squared. Remember that rotational inertia in general is some version of mr squared, and a disk is less than 1 because some of the mass is closer to the axis and some of it's farther away. So times alpha. We know mass, this radius is going to be 0.12 squared, and then I know everything in this problem to solve for alpha. Hopefully that helps. If you have clarifying questions, you can ask tomorrow during office hours.